Hello and welcome to this session on Docker Compose. Before we begin, let me just give you a brief overview of what Docker is. So I have other videos here in the channel about Docker, so you can follow those. However, just as a refresher, a Docker is a platform as a service product. Nowadays, Docker is not just a container, it's a platform as a service product that provide OS level virtualization to deliver software in packages called containers. Now, containers are isolated from one another and bundle their own software libraries and configuration files, and they can communicate with each other through well-defined channels. So Docker is basically a Docker container, as we call it, is basically a isolated entity where you can run your application, and it provides a layer of virtualization that is very closely coupled with the kernel of the operating system. And it is very fast to spin up, it is easy to build a Docker image, and also with orchestrators it can manage large-scale deployments. So we'll come to that in a while. Now let's jump into something that is very interesting, and that is the topic for today: Docker Compose. So what is Docker Compose? Why do we need it? What are the situations where Docker Compose come handy? And what are the use cases for Docker Compose? Is it production friendly or not? So we'll get to the bottom of it and answer all these questions, and we'll also explore how Docker Compose files are written, how Docker Compose works, and how we can use it to deploy multiple containers together, or you can say orchestrate containers. So let's get started. So multi-containers apps are a hassle. You will agree to it. Like say you have an app stack which contains multiple containers, not a single container. Say for example, you just have a website which is a HTML static website. Then not a problem. If you want to containerize that static website, just have Apache or Nginx server in a Docker container, and you have your code base there. And when the container spins up, you see that static website running in your Docker container. Or if you have a standalone database MySQL that you're running as a Docker container, then you just spin up an instance of that MySQL Docker container, and it listens on a certain ports and you can access it. So these are simple standalone Docker containers, and they are easy to manage. But imagine an application which has multiple Docker containers running together. For example, if you have a say LAMP stack, so there would be a Apache container obviously running on Linux, and then there would be a MySQL container, and there would be if there is a separate application server PHP container separately or with the Apache. So when you have multiple moving parts, everything depends on the other. So the first container will depend on the other to be able to perfectly function as a unit. So in these cases, when you have multiple Docker containers, there should be something to manage these multiple containers. So that becomes a problem. Management of multiple containers is a hassle, because you have to build images from Docker files. So there would be, say in case of a LAMP stack, you would have 3 different Docker containers, so 3 different Docker files. You have to pull images for the hub or private registry, and then configure and create those containers. To start and stop those containers, you have to repeatedly run those commands. Say I want to stop this stack which I am running, so I'll stop the PHP container, I'll stop the Apache container, I'll stop the MySQL, and then I can stop. And when I start, I have to start them. And there should be a particular sequence so that the application works perfectly fine. So it is a hassle, so not very user friendly. And some more reasons are you have to run a bunch of commands. Like you can see here, Docker pull, say you are running something which involves Redis and it involves Python containers. So you have to pull that image, and then you have to build that image, and then you have to run that image, and then you have to mount some volumes, and say you have to connect or link that image to another image which has a database. So these kind of things become very complicated when you are running multiple containers. For standalone it's fine, but when you are running multiple, it's not okay, because you have to run so many commands, you're bound to make mistakes, it will take more time. Not very useful when you are running complicated set of a software stack where there are multiple containers. So here again you can see you have to run multiple containers and multiple commands for each containers, and there is a lot of iteration or repetition. So it becomes redundant, like you have to write docker pull this, docker pull that, and then docker build this, docker build that, docker run this, that, and so on, and then linking the containers, mounting their volumes. So you have to keep a run book ready with the command list and you have to type it in. Not a very cool way to do things. So what is the solution? The solution here is Docker Compose. That's what we are going to discuss today. And Docker Compose is nothing but, you can say it's a binary which has sets of commands, and that allow us to have the all the containers running together and in one go. So how does that work? That is what I'm going to tell you now. Well, so what do we arrive at? With applications getting larger and larger as time goes by, it gets harder to manage them in a simple and reliable way. And that is where we have something called Docker Compose, and that comes into play to solve these problems of managing multiple containers. Now, Docker Compose allows us developers to write a YAML configuration file for our application service, which can then be started using a single command. This discussion will actually show you all the Docker Compose commands and the structure of that YAML configuration file, and you can just refer to this video and pause it anytime you like and recollect what has been said. So take it slow, because you're doing it for the first time, then you take it slow. And why do we care about Docker Compose? That is because there are multiple reasons to it, in fact. So first reason is Docker Compose lets you bring up a complete development environment with only one command, Docker Compose up, and tear it down just as easily as Docker Compose down. So you just write Docker Compose up, brings up the entire stack, Docker Compose down, brings down the entire stack. Very easy to manage. The second thing is its support for running unit and E2E tests in a quick and a repeatable fashion by putting them in their own environment. So it helps in testing. Like, say if testers are testing something, then it will be easy for them. And that means instead of getting the application on your localhost OS, you can run the environment that closely resembles the production. So you do not have to wait for some environment external to you to test your things. So you can test it on your own laptop by closely replicating what is in production. And multiple isolated environments can be created on a single host, because as I said, if you're running multiple containers, they have multiple isolated environments which you're running as a single host. So you can run multiple copies of the same environment on one machine, and it also helps you keep things separate so they don't jumble or interfere with each other. So these are the mostly the reasons why we use Docker Compose. And Compose was traditionally focused on development and testing, but now it can be used to manage whole deployment of containers on a single host system. So if you are running on one host, Docker Compose is your easy to use orchestrator. So when you're running on multi-host, then there are other tools like Docker Swarm, or you have tools like Kubernetes or Mesos Marathon to do that. But if you are orchestrating Docker containers on a single host, then you should go with Docker Compose. A lot simpler and hassle-free. So how do we install Docker Compose? First of all, if you are using Windows or a Mac like me, then if you install Docker Desktop, then let me pull up a Docker app. So if you install Docker Desktop, then you will see as soon as the Docker app launches, you already have Docker Compose installed in your command line. But in case you're not using a Mac or a Windows where you cannot install the Docker Desktop, then with Linux you can do it with certain commands. So that is these commands. So I will share this with a repository that I have created. So here is this repository. I'll share the link to the repository. So this contains the notes for Docker Compose. So this is my terminal. So if I do a Docker Compose version, I can see the Docker Compose version in my laptop. So that means I have Docker Compose installed in it. And for me, this is not Linux, this is Mac. So it came along with this Docker Desktop that I have installed in my system. So you can just Google it and install it. And if you are using Linux, you can use the commands that is attached in the PDF that is kept in that repository that I showed you. And there is one more thing. In this repository, you have this notes or the Docker Compose PDF file, which you can download. And if you click here, you will be able to see this video which we are talking in now. So you can refer this video as well. And well, you have some other useful resources which you can follow. All right, back to Docker Compose. So let's discuss about the structure of a Docker Compose file. So this is a sample Docker Compose file. So I'll explain you each and every line of this file so that you understand how a Docker Compose file looks like, what are the different directives and parameters that build the Docker Compose. And you should know that a Docker Compose file is a YAML file. So indentation is very important in this file. Just like Python, YAML requires correct indentation to work properly. So Compose allows developers like us to easily handle multiple Docker containers at once by applying many rules that are declared in a file. So these are declared in this file that is called a docker compose.yaml file. So the file which you are seeing in your screen is such a file, a docker compose.yaml file. It consists of multiple layers that are split using tab stops or spaces instead of braces, like we do in most programming languages, because these are YAMLs, so you don't have any braces in there, but there are tab stops and spaces all over the file, and that has to be adhered to, as I said. So every Docker Compose file should mostly include a version. The first line which you are seeing, that's the version. The services which will be built. So these are the services which will be built. DB, WordPress. So these two services are being built using this. So you will have two different containers, one for a database, one for a front end that is running a WordPress. So this sample file is telling us about the services. So it will also have volumes that will be mounted to these running services. For example, here you can see DB data volume is being mounted. So that is another thing that is mentioned in this file. And the network which connects the different services. So it will also talk about the ports in which the services will listen to and how they connect to each other. So these things, like for example, WordPress connects, depends on the DB. So that means this instance will come up first and then WordPress will come up so that it can connect to the DB. So you can see this is how the file looks like, a YAML file. And as you can see, this file contains a whole WordPress application, including a MySQL database. Each of these services is treated as a separate container that can be swapped in and out when you need it. Now that we know the basic structure of a Compose file, let's continue by looking at important concepts. So what are the concepts and keywords that are hidden inside this file? So one of the concepts here are the services. The services tag contains all the containers that are included in the Compose file that you can see here. Under services, you have the DB and the WordPress. So these two are contained under the services. So this tag services includes the different containers that are going to be running. And then comes the image tag. So that is under the name of the service. So that image tag is nothing but the Docker image that will be used when we are going to orchestrate that particular service. So if you want to run a DB server, the image that you are using here is MySQL 5.7. So this is the Docker image or the Docker repo name. If you are using a private repo, you will put it in the naming convention, like the private repo colon port number 5000 mostly slash the name of the Docker image colon the version. Or if you do not put a version, it normally takes the latest. So that is how Docker images are pulled. So this is nothing but the Docker image name. And then you can have some other stuff like restart always. What does that mean? These are other labels that tell you about the behavior of the container. Like for example, whenever you're rebooting your system, this container should be restarted. Then there is this tag volumes that defines which volume of the host system should be mounted inside the container and on which location. So if you have a DB data volume, this is nothing but a folder in your host system that will be mounted as a DB data inside varlib MySQL. So this is how the volume tags are mounted. Then there is a tag called ports, which you can see here. So here you can define the port mapping. So this WordPress listens on port 80 inside the container, and you're making it listen on port 8000 outside the container or in the host system. So that is how the port is mapped. And then you have other tags like environment. So this environment tag is nothing but defining the environment variables. So you want to pass a password for the database, or you want to pass some other variable, environment variable, into the container. So that you can do through these environment variables. So it is just a key value pair. So you have a key here and the value. So that is how you can pass environment variables. And this is very important in case of Docker Compose, because for example, say I want the WordPress to connect to a database. So where will I pass the database credentials, the database address, port, and so on? So I can save it as a variable, environment variable, and pass the credentials here. And in the config files, I can mention the environment variables, so that whenever the container is up, it passes the values inside the container so that application can connect to the database. So that is how environment variables are passed and how that is used. And finally, you can see this last line, volume and DB data. So volumes are Docker's preferred way of persisting data which is generated and used by Docker containers. They are completely managed by Docker and can be used to share data between containers and the host system. So as I said, these are nothing but folders of your host system which you need to mount inside the Docker container. So that is what happens with this directive. Okay, so here you can even mention the path of the volumes and mount it. Okay, so that is what volumes are. And so pretty much any Docker Compose file will look something like this, and there are certain ones which are even more complicated, but for now this is something which you should know. As we proceed and as I show you a demo of a real Docker Compose file, so then you will learn a bit more about it. So now what I'll do is I'll show you a real demonstration of Docker Compose. I'll explain all the files that are involved there, and that demonstration will help you understand and appreciate Docker Compose. So this is the repository where I have all the code files here. This is called Binpipe Docker Compose. I'll share this link in the description of the video so you can reach out this repo. So it contains the notes, as I said. It also contains the Docker Compose YAML file. I'll explain all this line by line. And then it contains the code base for the front end and back end of the application that we are going to deploy using Docker Compose. And in each of the application, there are the code files as well as the Docker file that builds the application. And then with the front end and back end deployed together, you get the entire stack up and running, and that is orchestrated by Docker Compose.yaml. Okay, so how are we going to use that, and what are the nitty-gritties? That is what we are going to discuss. So you'll have to check this out. I'll show you how. But still now, those who haven't been able to install Docker Compose, I'm reiterating again that if you're using Mac or Windows, you can install Docker Desktop and Docker Compose comes along with it. If you are using Linux, then you have to follow some steps. But anyway, here I have given you a link. If you click on that, that will take you to the Docker Compose installation steps, the official one, so you can use it for whatever operating system you are in to get Docker Compose installed. So I'm not getting into that. It is as simple as just running, copy pasting and running the commands that are mentioned here. For example, for Linux, just copy this command that will download Docker Compose, and then run this command that will put executable permissions. This creates a link to the user bin directory so that your Docker Compose command works from any location, and then you are done. This is the command to test whether Docker Compose is working or not with the version switch, so that it tells you which version you're on. Just as I ran this command, Docker Compose version, and I am on this particular version. And what are the other Docker command options, Docker Compose options? They are, you can type in Docker Compose and then just press enter. So it will give you all the different help commands. So this is just prints the help out here. So you can write Docker Compose and all the different arguments. So these are the different arguments, but I'll show you in course of the demonstration what are the most commonly ones that are used and what are the use cases. So here you have all the description. For example, if you write Docker Compose space build, then it will build a certain image, config, validates and views the config compose file, whether there is syntactical errors or something else. Then create creates new services, down brings down the all the services that were launched using Docker Compose, and so on. There are lots of command line options and their use cases. So to understand how does it all work, it would be better to move on to the demonstration. So first of all, we go back to the Docker Compose repository, which I showed you, and here we have all the code and the Docker Compose YAML file. So let's start from the beginning to understand the contents of this repository, and then I'll show you how to use Docker Compose to orchestrate these contents. So what are we going to build? We are going to build Docker images of backend and frontend. So that is the first task. So we have a software stack that has a front end and a back end. So it's a simple service that is written in Node.js, and the back end is in MongoDB. So you have a MongoDB flat file database and a front end, and we create a simple application to write your to-do lists. So that is written in Node.js. So you have this front end directory with all the code for the front end. So you have the package.json and all the JS files, and here you can see the HTML files, and here you can see the Node.js application components. So that is all about the contents of the front end. So we'll have a front end Docker container which is separate, and this is the Docker file that will build the front end Docker container. The intention is to explain you how you can use Docker Compose to build and deploy and run all with both the front end and the back end together. So that is the use of Docker Compose, where you are orchestrating multiple containers together using a certain wrapper, that is Docker Compose, instead of doing it one by one. So if I would have built the front end, then I would have entered into this directory front end, and then I would have written docker build -t, the name of the Docker file and its tag, and then the name of the container image, and then I would have built that. But now, since we are doing multiple Docker containers and we don't want to run repetitive commands, we are doing this. So what is inside the Docker file? As usual, it would have a from directive, like which image it is being pulled from, and these are all the various commands that will install Node.js and HTTP server. And then you have some environment variables that you are passing, and then you are doing npm run build after copying your package files, and you are getting a Node.js front-end server that is exposed at 8080. So pretty simple, and these are all the config files, etc., that are coming with this front-end server. Similarly, we have a backend server with its own package files, and we also use a MongoDB, as I said. Now the backend server is supplying all the data to the front end, so it also has Node.js and certain other components, and we also have a MongoDB which is defined in the Docker Compose.yaml. So what is in this Docker Compose? Because this is doing a bit of a complicated process of running both front and back end, connecting them together, connecting it to a MongoDB as well. So it's worthwhile to look into this Docker Compose file. So you know how the project structure now looks like when you have a Docker Compose here. So you have a Docker Compose outside, and then you have a front end and a back end folders that are present in the root, and when you go into that, you find their own Docker files that will be used to build those Node.js applications. So, and with the Docker file, I have already explained like how it looks like and what are the contents of that Docker file. So you have the from directive, you have the package.json, where you set which directory you are going to work in, and then you have the port exposed that tells you which port it will listen on, and then you have the cmd keyword where you are giving the start command for the node directory. So that is how these looks like. So going back to the docker compose file, here you can see the first line where we define the version. So here version is 3. After that we start defining the services that we need for the project to work. So you can see the services are Node.js, Mongo, and the front end. So these 3 will run and allow us to bring the entire stack up that contains the front end, the back end, and the MongoDB. So the Node.js uses the Docker file of the backend, which we created in the above directory that we saw, the backend directory, and it publishes the application on port 3000 to the host machine. And the service also depends upon the Mongo service. Here you can see depends on Mongo. This label explains that Node.js would not run unless Mongo is up, because it depends on Mongo. So next we define the Mongo DB service, which uses the default image provided on Docker Hub. So here you can see the MongoDB service, and this service also publishes a port to the host system and saves data of the database in a local folder. MongoDB by default listens on 27017, so that is what it is mapped to the host. And the last service that you see is the front end service, which is again Node.js, but it is for the front end file. So that is it, pretty simple. And you can use this as a template when you are building your own Docker Compose files. So just copy it, replace it with your services, and so on. And in most cases you don't even have to write Docker Compose, because if you search for similar projects in GitHub repositories, you get this. So you can just modify it according to your needs and run it. So you don't have to write it from scratch in normal cases. That is how, and that is what the beauty of collaborative working is. So you get content of the similar stuff that have been done by other people in the past. So you just need to know how to put them together and run them. So that is Docker Compose file for this project. So I'll show you how to build and then how to run it. So let's get back to the terminal. So here let me clear the screen again. So first thing what we'll do is to bring everything into our computer. So how do we do that? So we go back to our repository and we copy or clone the repository to our system. So I just copy this one. So you should also do the same when you are trying out this, and then go back to your terminal, and then you just type in git clone and the URL of the repository that you copied, and so that will clone the Docker Compose repositories. So you just type in Docker Compose, and with cd Docker Compose I enter into this repository. So if I do a listing, I can see everything in here. We have the backend, we have the front end, we have the Docker Compose.yaml. You can even do a vi and check the contents of Docker Compose.yaml. Here it is. So we have everything ready to set up our application and see it works or not. So before we do that, one thing has to be done, that is to put our IP address in the build docker.sh, because it will publish it in your IP address of your system. If you are using a Windows, it will automatically detect it, so you would not need it actually. But since I am using a Mac, it's not working with this default command, so I had to put in my IP address as the external IP. With Linux also you can do that by ifconfig command. That will show you your IP address. So for my laptop the IP address is this one, 192.168.10.100. So let me replace that with the IP address that is here, because you are with different Wi-Fi routers, so your IP address keeps changing. Alright, so that is the only thing that we did. Rest of the things are set. You don't have to configure anything else. So what do we do now? We have to build the Docker images and using Docker Compose. So Docker Compose, and that's where the magic happens. Like if you have gone through Docker and built Docker images, you would build it Docker images one at a time, but with Docker Compose we can build all the 3 Docker images all at once. So what do? We just type in Docker Compose build. But one thing you should remember, when you use Docker Compose command, you should be residing in a directory where the docker compose.yaml is, otherwise you'll see an error. So if I'm outside this folder where the docker compose isn't there, then this command would not it would not be fruitful. So since I am in the same root directory where docker compose.yaml is, so it will go and read the docker compose.yaml and understand what to build and then build it. So it is very important that you reside here, and then press enter. So then it starts building the Docker images that are mentioned in the docker compose.yaml. So here you can see it starts to build the Node.js image, successfully completed building it, and then you have the second image that is getting built. So it has certain packages to download and compile. So that is what it is doing. So it will take some time depending upon your network speed, and once that is done, we'll have all the 3 images built and ready to run. Then we will use Docker Compose again to up our instance or start up our instance, and then we'll see whether the front end, back end and the Mongo, all the instances are running together or not, and whether our front end is appearing properly in our browser or not. So we'll find that in a while. So once that is done, we are good to go and understand how Docker Compose works. So let's wait for this compilation to complete. Well, now we can see the Docker images have been built and the Docker Compose has concluded safely. So let's clear the screen. And now to start up, what are the commands that I'm going to run? Before that, let me just do a docker ps. So you can see nothing is up here. Now that we are going to run this docker compose command to start all the instances together, instead of having to run docker run one by one for the front end, back end and the MongoDB, we can use Docker Compose to run all of these together. So how do we do that? Just type in Docker Compose and you type in up. So that, as simple as that. So that will bring up all the Docker images together, and you can see the logs here on the screen as it is bringing everything up. So you can see it is bringing the front end up, and it brought the Mongo up, and it brought the Node.js or the backend up. So everything is up, and MongoDB is connected. Server is run. This is the server that is running on 3000, and so on. So here we go. We have everything up. Now to check it, we can just open up another terminal here, just to have a look at the different Docker containers that are running. So here you can see 3 different Docker containers are running: the front end, the back end and the Mongo. And we have our application listening on port 8080. So in the front end we have our application listening on port 8080. We can double check that by going into our browser. So if I type in localhost or the IP address 192.168, whatever was the IP address, that will give you the thing. So here you can see our front-end application of our app to-dos. So here you can add your to-dos. Say my to-do today is to learn Docker Compose, and I add it, so this goes to MongoDB as a record there. Then go to sleep early, that's another thing to do. Complete DevOps lessons. So that's how you just add your to-do lists, or if you have done something, already achieved something, like you have already learned about Docker Compose, so you just take it out so it gets removed from there. So this is just the application to demonstrate like how quickly you can deploy an entire front end, back end, and orchestrate it on a single host with multiple Docker containers together. So that is what I intended to show it. Now to remove or shut down the Docker Compose containers, what do we do? Since we did not use any flag when we did the Docker Compose up, so we can just do a Control-C to gracefully stop all the nodes. So it will stop. Okay, so once everything is stopped, our website will be down. So now if I go to the browser, it is here. So if I refresh it, you can see it's gone because we have stopped our container. And if you want to do this in a background, like if you want to start everything in a background, so you can just do Docker Compose up and then put a flag -d. Then what happens? It runs everything but does not throw the logs on this screen. So now it becomes a daemon and it runs in the background. So you can do anything else. You can run other commands here. You can do a docker ps. So you can do it on the same terminal. And even if you shut down your laptop, it doesn't shut down these processes. So that is why in a production setup, you should always use a -d if you are ever using it for something in production. So you can use -d with Docker Compose. But you might be wondering, what if I want to debug and check the logs in these cases? So we have another command, Docker Compose logs, to check the logs. So if you do that, you can see the logs at real time. Okay, and if you want to shut down your Docker containers, you can do that together as well using Docker Compose down. So that shuts down all the containers. So that is it about Docker Compose, and I'm happy that you made it all the way until the end and learned about Docker Compose, how to write a Docker Compose file, how to use it, and how to understand the directives inside a Docker Compose file. Spend some time with it so that you will understand more. Just search some good Docker Compose repositories in GitHub like this one, and then try them out and see how easy it is to run multiple containers together. So that will help you a lot to understand more and even get more creative with Docker Compose. And please post in your comments if you have any doubts. I am happy to help you out. So thanks a lot. Thanks for joining in. Have a great day.